So today we're going to be talking about trigonometric ratios, and really those help us talk about different angles. So I have an angle here, an angle theta. It has two sides, and actually I can take that angle and I can extend the sides so that I can make a right triangle. So I can make a right triangle with any angle, and when we look at the ratio of those sides, it's going to help us make some calculations about that angle. So my angle, I named theta. You really could name the angle whatever you want. You could have named it Bob. Mathematicians really like to name things with Greek letters. So this is the Greek letter theta, that zero with the little line over there. That's the Greek letter theta. And mathematicians really like to do that. They like to use short things, so they probably won't be using Bob. They're very efficient. So here we have our angle, and we're going to define some things in this new right triangle that we've created. So H is going to represent the hypotenuse. That's the side directly opposite of the right angle. We could take a diagonal line and connect right here. That way we always know we're going to get to the hypotenuse. A stands for the adjacent side. The adjacent side, the side that's touching the angle, the side next to the angle. O is the opposite side. It's directly opposite from the angle. Now we're going to look at some abbreviations. Oftentimes you won't even see this word written out, but we say it the same way. So you're probably just going to see the abbreviations, but I wanted to show you what they are abbreviations for. So sine, we abbreviate SIN. Not that you did something bad, and we actually say this as sine. Cosine, COS. Tangent, you have a nice tan here. Cosecant, and oftentimes we say tan here, tan of this, and cosine. So we just say the word tan instead of the tangent. We use both of them. But cosecant is abbreviated CSC, secant is abbreviated SEC, and cotangent is abbreviated COT. So now let's actually look at the ratios that we can develop with this triangle. So sine of theta is defined as the opposite over the hypotenuse. So we take whatever the opposite is over the hypotenuse. That ratio is the sine of theta. Cosine of theta is the adjacent side over the hypotenuse. So adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So we take the opposite side divided by the adjacent side. Now, cosecant is actually just the reverse, just the reciprocal of sine of theta. So cosecant is the hypotenuse over the opposite side. So hypotenuse over opposite. Secant is the reciprocal of cosine, or 1 over cosine. So we can think of that as the hypotenuse over the adjacent. So hypotenuse over adjacent, and cotangent is adjacent over opposite, which is just the reciprocal of what tangent is. Now the way I like to remember these is a little thing called Sohcahtoa. It just helps you remember what the ratios are. So S stands for sine, so for your so. OH, the O part of that, is opposite over hypotenuse. The C stands for cosine. The A stands for adjacent, and the H stands for hypotenuse. So ka. Toa, tangent, is the opposite over the adjacent. So Sohcahtoa. Okay, so say we're given the question, find all the trigonometric ratios for the angle theta. So here's our angle theta right here. Now let's first look at sine. Now sine of theta is the opposite over the hypotenuse. So opposite is 4 over hypotenuse. Okay, so we don't have the hypotenuse. So we can calculate this. This is a right triangle. So we can do a squared plus b squared equals c squared. So 3 squared, which is 9, plus 4 squared, which is 16, is a total of 25. So c squared, or this side squared, has to equal 9 plus 16, which is 25. And if we want this side, not this side squared, we take the square root and we get 5. So now we can find all of our ratios. So if we look at sine theta, opposite over hypotenuse, 4 over hypotenuse, which is 4 over 5. Cosine is going to be the adjacent over the hypotenuse. So 3 over 5. Tangent is going to be opposite over adjacent. So 4 over 3. Whew, this one's wrong. So 4 over 3. Cosecant is going to be hypotenuse over the opposite. So 5 over 4. 5 over 4. Secant is going to be the hypotenuse over the adjacent. 5 over 3. And cotangent is going to be the adjacent over the opposite. So 3 over 4. 3 over 4. Now that's not the only angle in here that we can actually find the trig ratios for. There's another angle up here, and let's see if we can find the trig ratios in this same triangle, but this angle instead. We'll have to give it a different name. So let's give it the name beta. That's another Greek letter, so we're going to call it beta. Now we're going to look at the sine of beta instead of the sine of theta this time. So the sine of beta is the opposite over hypotenuse. Now it's opposite of beta, so we have to look opposite of beta, which is 3. The hypotenuse is still 5, so it's going to be 3 over 5. Now let's look at the cosine of beta. The cosine of beta is the adjacent over the hypotenuse. So let's look at the adjacent side. The adjacent side to beta is 4. So we're going to take 4 over 5, or 4/5. Tangent is opposite over adjacent, so opposite over adjacent, 3 over 4. Cosecant of beta is just the reciprocal of the sine of beta. So once I have these 3 trigonometric ratios, I can actually calculate these without looking at the triangle. I can just take the reciprocal. So cosine of beta is going to be the reciprocal of 3/5, which is just 5/3. The secant of beta is going to be the reciprocal of 4/5, which is just 5/4. And the cotangent of beta is going to be the reciprocal of the tangent of beta. Tangent of beta is 3/4, so the reciprocal is 4/3.